So now what is acceleration? Basically the rate of change of velocity is known as acceleration, right? So now what is the formula of this acceleration? The acceleration basically stands for change in velocity upon change in time, like how much velocity has changed in the rate of time, right? So this is the formula of basically acceleration. Now, is the acceleration vector or a scalar quantity? So basically this acceleration is a vector quantity, right? Now what about its unit? So its unit is basically meter per second square. This is the unit of velocity, right? Now basically we have two types of velocity, like we have one velocity known as deceleration. Deacceleration or deceleration, it means when the velocity actually decreases, or you can say the direction of velocity is opposite to the direction of acceleration. The direction of velocity is opposite to the direction of acceleration, then the body is said to be in deceleration, or you can say the velocity is decreasing. The velocity is decreasing, so that is termed as deceleration, right? Now what is acceleration? Acceleration is when the acceleration is when the direction of velocity and direction of acceleration are same. At that time we can say that this is basically acceleration, right? Now let's talk about an important point, that you know that it is possible, like it is very important point, note this thing, that it is possible that the body has velocity which is equal to 0, but acceleration is not equal to 0, which is sign of not equal to, basically okay, I'm unable to find, let's put it by myself, right? So it is possible that body has velocity is equal to 0 but acceleration is not equal to 0. Now which is this case? Basically this is the case motion under gravity. We will study this thing too, basically. Now what happens, basically, if consider that here I'm having okay, here I'm having a ball, right? And I'm throwing this upward. Now I'm throwing this upward, and at a certain height, like don't consider this as a projectile. Okay, we know that initial velocity will be something, but the final velocity will be 0, and the initial velocity when it will come down will also 0. It means here the velocity is equal to 0, but we know that the acceleration is acting, which is acting downward, right? Acceleration is downward. And what is what is gravity? Like gravity is acting over here, right? And what is gravity? Gravity is actually the acceleration. It means that there is acceleration, but the velocity is 0. It means, so a body can have 0 velocity and acceleration will be not equal to 0, but there will be certain magnitude of that acceleration, which is basically 9 0.8 meter per second square, which is the magnitude of this gravity, which is this acceleration. So it is very important point to note down. Right. So now we have certain types of accelerations, right? So let's just study the types of acceleration. Okay, number one we have, which is uniform acceleration. So basically it is when the body does not changes its body covers equal velocity and equal interval of time that is known as uniform acceleration. Like the change in velocity is equal in equal interval of time. Right? So this is basically known as uniform acceleration. Let's have the graph of uniform acceleration. Okay, so let's have the acceleration over here. Okay, you can see over here we are talking about the uniform acceleration. Now let's see if we have any graph. Okay, here we have the graph of, let me maximize this. Okay, as you can see over here, we have the graph of this uniform acceleration, and which is basically the straight graph as the speed and the time is changing in there is an equal change in equal interval of time. So this is basically the graph of this uniform acceleration, right? So now next we have, which is the variable acceleration, or you can say non-uniform acceleration. We have other, which is non-uniform acceleration, right? Now if a body if a body if a body if a body does not change its velocity in equal interval of time, that is known as basically the non-uniform velocity, right? So what about the graph of non-uniform velocity? Let me draw it by myself. It's quite easy, right? So here I'm having this axis. This is known as x-axis, and it is having y-axis, and at x-axis we put a quantity which is independent. So over here we'll put time, which is basically independent of anything, and here we'll put velocity. Okay, one more important thing, that these graph of acceleration are known as velocity time graphs. These are basically known as velocity time graphs, right? So let's make the graph of variable acceleration, or you can say non-uniform acceleration. It is like this, something like this, okay? Or you can say it can be like this, or whatever do you feel like, right? So parabola, hyperbola is upon you. Okay, now we have instantaneous velocity acceleration, right? Instantaneous acceleration, right? Now, what is this basically? Instantaneous acceleration is basically the acceleration at a instant point acceleration. The acceleration at an instant point is known as instantaneous acceleration. Acceleration at an instant point. For example, like let's consider this one graph we are having here. Like this is point A and this is point B. Now I want you to tell me the acceleration at this point, to the midpoint, right? Like this instant. That is known as instantaneous acceleration, right? So the formula for this is like instantaneous acceleration is equal to change in velocity per unit time, but the time approaches to zero. So this is basically the formula for the acceleration, the instantaneous acceleration. Like time approaches to zero, like at the instant point. So when we talk about any instant point, we say that the time approaches to zero. So I hope this is clear to you. And if you have any kind of queries, you can ask me in the comment section. I'll be very glad to answer you guys.